So equivalence means having the same value. And we can use the understanding of equivalent to show that we can write a number in many different ways using various operations. So let's take the number 10, for example. And of course, this is written in red, so you're going to want to write down all of the examples I have on this particular slide. So we can write the number 10 in different ways. If we want to use addition, we can write the number 10 as 1 plus 9. We can write the number 10 as 2 plus 8. We can write the number 10 as 3 plus 7. We can write the number 10 as 4 plus 6. Or we can write the number 10 as 5 plus 5. All of these are equivalent values. They're equivalent because they have the same value. If we want to use subtraction, we could write the number 10 in several different ways. I mean, really an infinite number of ways. Let's say we do 20 minus 10, or 30 minus 20, or 40 minus 30. There are an infinite number of ways that we could write the number 10 or rewrite the number 10 using subtraction. What if we wanted to use multiplication? If we wanted to rewrite the number 10 using multiplication, we could write 1 times 10. And just a side note here, I'm going to try whenever possible to use the multiplication dot instead of the x, because as the year goes on, we're going to be moving towards that, and we will actually be using the x for something else. So I want you to get familiar, to become familiar with the multiplication dot. So we can also write 10 as 2 times 5. Those are equivalent because they have the same value. And what about division? We could write 10 as the quotient of 100 divided by 10, or 500 divided by, oh my goodness, what is, let's see, 500 divided by 50. There we go, that's what I meant to write, 500 divided by 50. So there are many different ways we could write 10 using division. All of these numbers are equivalent. But what if we wanted to write a number rewrite a number, so an equivalent number, using more than one operation? So let's take the number 20. All right, so we're going to start with the number 20, and let's say that we want to write the number 20 using addition and multiplication. Well, let's rewrite the number 20 as two different numbers with addition first. So let's say I want to write this as 15 plus 5. Well, once I have 15 plus 5, I can then rewrite that using multiplication and keeping the addition there. So I can rewrite 15 as 3 times 5, so that's 15, and then I can keep the plus 5. So now I have rewritten the number 20 using two different operations. All of these are equivalent, they all have the same value, but one contains no operations, this contains one operation, and this contains two operations. So this is demonstrating what equivalence is, and this is important for understanding the distributive property, that we can rewrite numbers in different ways using various operations, but they still have the same value. If we want to use the distributive property to write an equivalent number, so to write a number in an equivalent way using operations, the distributive property has a specific format. And so the distributive property is just, it's one way to rewrite a number, or you can even rewrite several numbers in a different way, an equivalent way, but it has a specific format. And that specific format, which you may have found when you defined the word distributive property or the phrase distributive property, is a number. So I'm going to write a number here, and times the sum of two other numbers. So that is what the distributive property is. So I'm going to use some examples now, some example numbers. So let's say I have 2 and then 3 plus 4. Well, I can use the order of operations to write this as an equivalent number. So I know that 3 plus 4, I want to do my parentheses first, and that is 7. And then I'm still going to multiply by 2 because this really tells us multiplication. And so we have a little side note here. This is important, how to show multiplication. And of course, you want to write all of this down in red, write everything that's in red. So we can show multiplication as the x that we're used to. So let's say 2 times 3. We can use the multiplication dot, or we can use parentheses. So that's not a good parentheses. There we go. If I put a number next to something in parentheses, that means multiplication. So this means 2 times 3. Or I could even put the 2 and the 3 in parentheses, and that means 2 times 3. All of these mean 2 times 3. So just be aware of that. So really this means 2 times 3 plus 4, whatever 3 plus 4 is. So now we have 2 times 7. If you want to keep the parentheses around that, you can, but we've already performed that operation, so you could leave them off if you wanted and just write 2 times 7. And then 2 times 7 is 14. So I can write the number 14 as this, or I can write this as the number 14. Those are all equivalent. Let's look at another one. Let's say we have 3, and it'll be times 2 plus 5. So that is one way to write whatever this is equivalent to. I'm going to do my order of operations. 2 plus 5 is 7. And then I haven't done 3 times 7 yet. And again, if you want to write your little dot there, you can. And 3 times 7 is 21. So there are 3 different ways now that I have written the same value. All 3 of these are equivalent because they are writing the same value in 3 different ways. But this is using the distributive property, this very specific format to rewrite a number. And that's what the distributive property is. The distributive property says I can go from this form, so a number times a number plus a number. I can go from that form to a single number and back and forth. So I can go and I can write a number in both of these formats, either as a whole number or in the distributive property format, and they are equivalent. So we're going to use the distributive property now to write a number in an equivalent form, but following the distributive property format. So let's start with 14. And I know that I'm going to need to get to the format of a number times a number plus another number, because that's the distributive property format. But I need a middle step. I can't just go from here, from my whole number to my distributive property. I have to figure out that sort of middle part to know which numbers I'm going to use. So the first thing I'm going to do is I'm going to rewrite 14 with multiplication as a product. So the way I can rewrite 14 as a product is 2 times 7. So 2 times 7 is equivalent to 14. Well, now I have this part. I have the 2 times the sum of what's in that parentheses. So now, excuse me, now I can go to my third or my final step and say, okay, the 2 is here and this is going to be times. Well, how can I rewrite 7 using addition? Let's say 3 plus 4. There are other ways to write it. So if you used 4 plus 3 or 2 plus 5 or 6 plus 1 or whatever, that would be just fine. But 3 plus 4 is what I chose. And so now I have rewritten 14 using the distributive property. I took a number and I split it up using multiplication first, and then I took one of the numbers that I had in the multiplication part and split that using addition, or rewrote that using addition. Let's look at another example. So let's take the number 25, and I want to get to the distributive property format, which is a number times 2 other numbers added together. So first I need to rewrite this as a product. So to multiply 2 numbers together to get 25, I really only have one choice, which is 5 times 5. I could use 25 times 1, but that's not really that helpful because I still have the number 25. So I have 5 times 5. So I have my first number here now, and I have what's going to be the sum of the 2 numbers in my parentheses. So now I can do the third step. I have 5 times, let's say 3 plus 2. So now I have written the number 25 in the distributive property format. That is how the distributive property works. And if I go from the distributive property back to my number, that works because then I can say 3 plus 2 is 5, and then 5 times 5 is 25. We're going to use this example, this last example, to show the final piece of the distributive property. Now that you understand how to rewrite a number in the distributive property format, we're going to show what the distributive property format can be rewritten as. So let's do the number 16, and we want to write it in the distributive property format. So first we need to break this up into, or not break this up, rewrite this as a product. So let's do 2 times 8, and then rewrite the 8 as a sum. So 2 times, let's do 3 plus 5. Now, here's the important part of the distributive property. The distributive property is telling me that I have 2 of what's in my parentheses, which here is 3 plus 5. So I have 2 of those. So I really have a 3 plus 5, and I have a 3 plus 5. Well, 3 plus 5 is 8, and 3 plus 5 is 8, and 8 plus 8 is 16. The other thing that this tells me is that, I'll rewrite my distributive property here. If I have a 3 plus 5 and a 3 plus 5, that means I have 2 3s, okay, 1, 2, and I have 2 5s. 1, 2. And if I do 2 times 3, which is 6, and 2 times 5, which is 10, 6 plus 10 is 16. So once I have my value as the distributive property, it's true, and I can rewrite it, it's equivalent, as 2 of this plus 2 of this, and it's equivalent to my original number. If we think back to the examples, for example 1, which was the number 14, we rewrote it as 2 times 3 plus 4 because it was 2 times 7. This means I have 2 3s, and if I add it to the 2 4s that I have, that will give me 6 plus 8, which is 14. And if we think back to example 2, which was 25, and we rewrote that using the distributive property as 5 times the sum of 2 plus 3, that means I have 5 2s, and if I add that to the 5 3s I have, 5 times 2 is 10, 5 times 3 is 15, 10 plus 15 is 25. So there are 3 different ways that I can write a number in the distributive property. I can write a distributive property number, so let's go back to 16, which is example 3. I can write 16 as a whole number. I can write 16 in the expanded distributive property format, 2 times 3 plus 5, and I can write the number 16 in what we call the distributed format, the distributed distributive property format, which is 2 3s, that's what I have, plus the 2 5s. All of these are equivalent. 16, this is also 16, and this is also 16. All of those are equivalent using the distributive property.